So upon running the code, we are given a GUI. Right now it's showing Tesla, and from the GUI, we can cycle through by searching the tickers from the watch list by just typing through the GUI. So right now we have Tesla, change to NVIDIA, then I've Go, AMD, and Baba. If you've noticed that each time it updates the chart as well as the SMAs in the chart. It also shows the volume of the trades that was given by Yahoo Finance. Also here below, printed on the console, you have the tickers that have the fast moving average above the slower moving average printed here below. Now running through the code, I'll first move on to the getting the data. Now I chose Yahoo Finance because it was straightforward and free. But however, this can be modified to another data provider and the chart can be converted into live data feed. I used 3 parameters to get the query download link for the ticker symbol. This one, the period, the start period, and the end period. The end period is taken as now from datetime, while I used a function to compute for the start period. Now, for example, you gave me or you required me to use 60 days of data. And also, since there are no data on the weekends and market holidays, so I took into consideration for checking for weekends and omitting them in the computation. So also, it's noted that there are 20 market holidays for 2023. However, I added another 12 days of data, 10 being the holidays, to consider the holidays, and another 2 for unforeseen, just a buffer for unforeseen market closes. Now, this is the logic to check if it's a weekday or not, and it returns the timestamp for the start date. Now, this is the actual function that executes the download. We have the read after it's been downloaded, read into a CSV. We define the CSV name here. Then to save the CSV, save the data frame as a CSV. It also has the mode write, so even if you, it will just overwrite existing tickers if the CSV file is already existing. Now, one thing to note, that I also place a function that waits to check that the file has been successfully downloaded before moving on to the next line of code. I think this is particularly important not to output too many requests to the server that might result to IP banning. So again, this waits and checks if the file already exists in the directory. It also ties in with the next function, which is the watchlist download. It takes in the watchlist from the initial parameters and the number of candles. It loops through the watchlist, executing the download function. And saves the CSV as raw data that has not been transformed yet. So on the raw data, this is what you can expect. You have a date, open, high, low, close, adjusted close, and volume. Now, I also want to note that I chose not to over exceed the start date. For example, if you wanted me to, or if you wanted to get 60 days of data, and it would have been easier if I would just go download 120 days of data than just to trim it afterwards. But I think that's a waste of resources, especially when scaling up. So instead, I that's the reason why I made a computation, a function for computation for the start date that's closest to the exact number of data that you want to see. In this case, 60 days plus 12 days of extra data to consider the holidays. Now for the main function, back to main.py. Main function has some helper functions. The get bar data is a helper function that loads and transforms a CSV into a data frame. Here is the transformation, loading of the CSV file. Now here's the transformation and the cleanup of the data frame. I chose to drop the close column on the data frame, and instead I wanted to use the adjusted close as the close for the chart computation, or rather for the candles. And here I trimmed the data frames, that I trimmed the data frame to the exact number of candles as specified on the parameter. Now next, this is the computation for the SMA. It takes in the cleaned data frame and the SMA period from the parameters. I'll get back to the function later. Now this outputs a tuple. Now this section here is for the callback. This section here is for the callbacks. Now on the onSearch function, it handles the data handling and the updating when a search is invoked in the GUI. I have there the unpacking of the tuple, and this would be the updating of this here is updating the charts and updating the lines, the SMA lines data. Yeah. This area, especially here, this is the from the library of Tradingview, the light uh, lightweight charts. This would be the settings for the charts, for the chart that's going to be built. I have the unpacking of the data. This is to add the indicators, the SMA, the slow SMA and the faster SMA. This is to set the data for the SMAs, set the chart data, and this one is to create the chart itself. Now this function is the one responsible for computation for if the SMA is above or below the slower one, or the faster if it's above or below the slower one. It just loops through the watch list and takes in the SMA period as the parameters, computes them and outputs. If it is above, it will print. If it's not, then it will just skip it. Now onto the indicator. This is the indicators.py. The logic behind here is very straightforward. It uses the transformed data frame and the time period for the computation. Now I acknowledge that I think this can still be refactored to use a single function, which I'll get back to in the future. Now this script is very dynamic. by changing the parameters, the charts can change, and we can add the number of days of data. You can add more to the watch list, change the SMA period. So in this second example, I'll just change it to 120 days of data. I'll add in Apple. Change this to 30 and 15. Now I'll just uncomment this section. This is the one. This is the function that calls for the download of the data. Just save and clear, rerun. As you can see, as soon as it's downloaded, it gives you a prompt that that's downloaded successfully. There. So now, this is exactly 120 days of data. The SMA has adjusted accordingly as well. If I change it to Tesla, same thing. Nvidia. All right, so that's about it. I'll leave the link to the GitHub repo on the description